A hearty good afternoon to you, ladies and gentlemen who have logged into our webinar. Let me first thank you profusely for taking the time from your busy schedules and joining us for this technical session. I'm sure the name FieldComm Group is very familiar to you because we have been there for quite some time. And I believe there are no plants today which are not using our technology in one way or the other. For the benefit of people who have just logged in, let me introduce to you what the FieldComm Group is all about the existence here in India, which has been there for more than, I would say, 12 to 13 years now, maybe more. Something about the mission statement, what kind of technologies FieldComm Group encompasses, and something about Ethernet-APL to begin with, what the topic of today. So about the FieldComm Group, we are basically a global standards organization. We set the standards for the communication or implementing the communication technologies for the process industries. We are a non-profit organization, and in fact, the three technologies which are also shown in the logo on the right-hand side, HART, Foundation FieldBUS, and FDI already exist. And for that matter, I'm sure many of you are already using HART devices or Foundation FieldBUS devices. In fact, HART is one of the most used communication protocols in the process industry, and I would say with a coverage base of more than 70 or 80%, other than the remaining ones are primarily just the analog signals and the Foundation FieldBUS. But all said and done, these three technologies have been there for some time, yes, but the the technology and the upgradation is what we are coming up with. What is our mission? We basically promote a global standard for integrating digital devices, may it be on-site, mobile, or cloud-based solutions. So the standards organization, the standards conformance and implementation basically helps in multi-vendor interoperability. That means no matter which manufacturer is making the products or the control systems. Of course, it will be open to the extent that yes, they will be interoperable, something which is a bottom line for any process industry. The first one, which very briefly I'm going to speak about, is the FDI. FDI is basically one package. We had device drivers and ADDLs for various communication protocols. May it be HART, may it be Foundation FieldBUS, may it be Profibus, or may it be Profinet, or many others for that matter, and even some proprietary ones. But our idea was that the FDI should be only one package that is available, and by downloading the one FDI, you should be able to automatically configure your device into the control system. We are endorsed by groups like NAMUR, which is one of the biggest chemical association of European Union, and of course even organizations like Profibus and OPC are a part of our venture or our I would say team. It is not something that we are doing on our own. There are many companies who support us like ABB, Anderson-Hauser, Emerson, Honeywell, Invensys, Siemens, Yokogawa. So there are many organizations which I believe Jegajith will also talk about. And the last, of course, is the Foundation FieldBUS, which has been there in India. And India is also one of the big users of the Foundation FieldBUS devices, with one of the biggest installation being there in Reliance and also now in other refineries. HART, something which has been in use for many years, for more than 25 years. And the new development that you can foresee or you can expect is on HART IP. HART IP is already existing, by the way, if I have to say so, but not too many devices are working on HART IP. What is HART IP? HART IP is basically HART on Ethernet. So right now we know of HART only as an overriding signal on the current line or on the analog line. Basically with a frequency modulation. Whereas on HART IP, we will have HART directly on Ethernet, which will of course have its own set of advantages. FieldComm Group India Society is already existing for quite some time. And we have a chairman from Anupam Srivastava, who's from Emerson. We have Vaibhav Shetty, who's actually the vice chairman, and he's from Pepple and Fuchs. I work for Chemtrol's Industries, and our CEO of EIP is our treasurer, Mr. Ravindra Goel. So all these people are available to you, and I would urge each and every one of you to be a member of our group. Do remember that the end users membership is free of cost, and you will get updates as and when they are launched by the FieldComm Group. And of course, the corporate membership is also available for a small fee, where all the vendors who are actually producing products or making instruments or control systems are basically a part of the corporate membership. So the corporate membership has a small money on it because of many other reasons, whereas the end user membership is free for one and all. Talking of today's seminar on Ethernet-APL, I know many of you have already heard about Ethernet-APL, which is a building block for process automation digitalization. And of course, it will bring with it the advantages of high-speed bandwidth of Ethernet, and also the advantages of Ethernet. And one of the big things that we will bring in is a very easy, I would say, way to move this technology to comply with Industry 4 norms and Industrial Internet of Things, that is the IIoT. It will be the preferred architecture for process automation in the near days to come. And many companies are working towards developing products and the control systems based on it. And this has been a need for quite some time, and now it's taking reality. Today's speaker is Mr. Jegajith. So I have the honor of introducing Jegajith to you. He's an electronics and embedded systems expert with more than 15 years of experience. He has a proven expertise in leading and coordinating teams of embedded systems, in development of software, firmware, and integrated embedded systems and IoT devices. And he is also very experienced in researching, evaluating, and synthesizing technical information to design electronics, firmware, and software. Their company, Utthunga, is already into this business for quite some time and has been helping many companies in India to develop protocols for their products and devices. So without much ado, let me just pass the presentation baton to Mr. Jegajith to go ahead and make a presentation on Ethernet-APL. So over to you, Jegajith.
Thank you. Harish, I think my screen is visible to you.
Yes, it is visible. Go ahead.
First of all, thank you, Harish, and welcome everyone to today's topic. So today we are going to talk about advanced physical layer. So before starting, let me introduce our company. Our company is Utthunga. Utthunga means pinnacle. So we want to scale up our technologies and customers to the heights. And we are a 600 plus professional company, and we are existent since 14 plus years, and we are located in 4 locations worldwide: USA, Germany, and Japan. And Bangalore is our headquarters, and we have been working with almost 50 plus customers and 100 plus products. And we are ISO 9001 2015 certified, and we are also certified ISO 27001, which is an information security. And see, our we are able to increase releases up to 40%, and our one of the main USP is a co-creation partnership, where we work with customer to understand their non-articulated requirement or any other field related things, and jointly we'll work with customer to develop the products. And since we provide multiple solutions in single umbrella, we are able to reduce vendor management for the customer. So it's like a single vendor for multiple requirements. So with that, reduced TCO, which is a total cost of ownership, has been come down. So our focus, we are focused companies into industrial automation control, power and utilities, building automation control, and motion and mobility. That is our segment of focus. All this focus, our offering is digital engineering, operational applications, product application engineering, and embedded engineering. So these are the different technological vertical we are handling in our organization. And all these things, we are providing the connectivity and data solutions, which we are very strong in connectivity aspects in terms of industrial protocols or any other wireless technologies. And security engineering is also one of our strong area, where everything is connected to the cloud, and connectivity is the biggest thing where since we need to ensure the secure connectivity, so cyber security also one of our strong area. And verification validation is also another strong area which we are serving to complete engineering aspects, where we do a lot of verification on protocols and other testing aspects. So already Harish has given my introduction, so skipping that. So today agenda, I'm going to introduce about what is APL and the general automation pyramid, how it is connected from field device to the cloud or any ERP systems, and process automation communication system, and Ethernet comparison based on the OSL model, and Ethernet-APL, what exactly it is, and various network examples, because when we talk about instrumentation, it definitely we need to talk about the different networks, and migration to APL with the existing product, how we can migrate to APL, and final conclusion. So APL again, it's an advanced physical layer Ethernet communication for sensors and actuators, which is, I would say, the first two-wire Ethernet connectivity, which is for field devices, which we called as 10-base T1L and IEEE standard 802.3CG 2019. So the leading companies are working for this standardization, especially FieldBUS, ODBA, FieldComm Group, and these are the major companies or consortium contributing to this APL working group. So what happened APL once it is realized? So as you know, the most of the device what we are using in the field, which may be connecting to the operation layer, which we can say the OT layer through a gateway or some other interfaces. So by realizing this APL connectivity, we are creating one physical medium of sensors or any device to the cloud. So that's the main advantage. So it's like from your field device to your enterprises or your cloud devices, we are using one technology called Ethernet. So this is our typical automation pyramid. So as you can see that level 0, most of the things are production and process. Level 1 is sensing and manipulating, where a lot of gateways, PLCs, and other interfaces devices are present. And the monitoring and supervising is on the SCADA and HMI, and then further ERP and manufacturing business process related things. So all this vertical now realization of APL. So from level 0 to level 4, we are going to use one technology, Ethernet. The only difference is that when it is coming to the field level devices, we are going to use a two-wire Ethernet, which is capable of giving power to the field. We'll do a very detailed discussion in further slide. And across all these platforms, cybersecurity also a crucial element, because while enabling connectivity to the field level by giving an open protocol like an Ethernet, cybersecurity is the biggest concern. So we are not going a detailed discussion about the cybersecurity aspects, but there are different methods which we'll discuss in our further slide. So let's look into the history, how the process automation is connecting, or how the field device connectivity is realized till today. So already Harish mentioned that it's a HART, predominantly 40 million devices are powered, or 60% of the process automation is using HART as a communication interface. So HART is basically a 4 to 20 milliampere current loop, which is again encoded by two frequency levels. So one frequency represents data 1 and another frequency represents 0. So in an analog signal like a 4 to 20 milliampere signal, when we are superimposing a higher frequency which is modulated with a different two frequency, we are able to transmit a current data, which is, I would say, 4 milliampere. Let's represent a 0% opening of a valve, and 20 milliampere represent maybe 100% opening of a valve. So by varying this current, in fact, you are controlling something to the field or some set point. On top of it, we are giving a digital communication interfaces, which means that we are controlling the element through analog and as well as a digital. And this entire data is transmitted over a frequency shift key. That's what I said. Each frequency represents 1 and 0. So it is like a single wire interfaces, which can be powered to field by providing 4 to 20 milliampere power and as well as data. So both digital and analog working in a single wire communications. It's basically a low power communications. So these are the HART commands. So HART again specified by this FieldComm Group, and there are some certain standards which is divided into universal commands, common practice, and device-specific commands. I'm not going in detail, but these commands has a lot of special need. Like say example, command device-specific commands is something like that specific to the device. Example, if you are taking a temperature controller, the PID value setups or something on the temperature configurations or what kind of input device and how do we calibrate. So those things are captured in the device specific commands, and there are HART specification recommended commands, which is universal and common practice commands. So we are bound with these HART commands, especially when we are talking about 4 to 20 milliampere communications. But when we go to Ethernet kind of a protocols where it can work with any industrial protocol which support Ethernet. So this is our typical HART architecture when we talks about a HART device or a handheld devices. So you can see the SCADA and DCS, which is again connected with an Ethernet. So HART IP is something, a protocol on top of Ethernet, so that this can talk to a SCADA devices over Ethernet connection. There are IO subsystem, which is again HART devices for the field. This can be powered using its low power devices, or it can control the various parameters also. Again, when you talk about the HART IP also, there are multiplexers which is connected to Ethernet IP, and multiple ports can be connected to devices. Again, HART has another version called wireless HART, which is working on 2.4 gigahertz. So in this network, again, HART IP is connected to a wireless HART gateway, which is broadcasting, or it support a kind of a gateway system, and with that mesh network, you can connect a multiple wireless HART device also. So this is a typical when it talks about a HART architecture for both field level control to the SCADA level or up to the cloud level. This is a very typical architecture which I'm covering the HART IP, and as well as for a standard HART device, and as well as the wireless HART. So Ethernet as a general comparison, because Ethernet, as I discussed, I think any college students understand what exactly the Ethernet. So that has made a significant impact in not only the industrial automation side, everywhere connectivity is happening over Ethernet, and Ethernet has a multiple flavors, which is on in terms of speed, in terms of wireless connectivity. But when it talks about process automation, it is little critical, right? Because process, again, when we talks about oil and gas industry or any other process aspects, safety is the biggest criteria. So when it talks about APL, safety is one aspect which the standard considered, and next is the environmental standard, because this can be operated in a hazardous area where the power and energy has to limit. It should not create any ignition, or an energy should not cause any ignition. Again, deployment and connectivity solution and business benefit, because as you already know, the RJ45 connector, which is again a special connector, I would say, when it talks about industrial automation side, that kind of delicate connector is not suitable. Really, it's need a ruggedized connector. Of course, it has to give some business benefit also in terms of connector or in terms of deployment. So considering all these things with the 20+ years of domain expertise and subject, we are introducing new APL technology. Let's see how it is architected and what is the specification of that. So this is just a comparison of how the connectivity aspects is working. So this is technology. Here I'm comparing technology, media, measurement, local access to the data, and remote data access, which is the cloud connectivity aspect. So this is some kind of an industry revolution, like pneumatics. Basically, it is the medium is air, and it can control one value. Basically, it will set one set point, either it is on or off. Similar way, 4 to 20 milliampere, yes, it's a pure and low control. Again, it is controlled one value, or 4 to 20 milliampere. What are the maximum distance? Like say example, if I'm taking one value, means if I'm controlling a valve and it has 0% to 90% or 0% to 100%, value means that the valve position. That's what it means here. So with this varying this current, we can control that value from 0% to 90%. By addition to HART, like I said, discussed on top of this current, we are adding a digital medium, analog and a digital serial communication. We can control one plus n values. Like here we are talking about the position. Sometimes we can set the values for 4 to 20 milliampere plus HART. Of course, when it is connecting to the network, we had seen in the previous slide, by connecting a gateway, we can connect to the ERP system or SCADA or cloud. And remote access is also possible using a gateway system. So when it talks about FieldBUS, yes, this is also similar architecture, and this is also working with purely on digital differential signals, and that can also transmit n values, and local access to the data is integrated. Gateway is required for a upper level communication, which means a different standard of communication to the cloud or any other ERP systems or any other scanner. When you talk about Ethernet, see, Ethernet is again a technology. Ethernet media it supported various network, and it can support n values, and again local data to remote data is integrated. So when you talk about Ethernet, since the gateway, in terms of communication protocol, we may require some gateway, but when it talks about as a technology from field level to the enterprises level, we are using one technology. So this is a general comparison in the industrial revolution aspects. So these are the organization in working group. These companies are, you guys are familiar with these companies. So this is some Ethernet-APL journey. Some 2015 proof of first concept is started, and new IEC technical specification is the second stage. And there are some 5 chip launch. Recently, there are few 5 chips launched from some non-semiconductor companies. And 2018 official APL project started, and 2021 it's supposed to launch. Because of this COVID and other things are getting slowed down in the semiconductor field, but the chips are available. Utthunga is again partner with many other semiconductor companies, and we can announce that we are ready with our reference design. So this is our OSI structure. So where exactly the Ethernet-APL is going to impact. So when you see OSI 7 layer architecture, so our physical medium design decide what kind of connectivity it is. So it has a multiple connectivity aspects like Ethernet, fast Ethernet, Jegajith, and Wi-Fi, which is a WLAN connectivity. So the same place this Ethernet-APL is replacing with a 2-wire connectivity. Rest of the layers are intact, or there is no change in the rest of the layers. Say example, if Ethernet IP or HART IP or OPC UA, so any Ethernet supported protocol can work on Ethernet-APL. So that's the beauty of this technology, and there is no much changes on the software side. So only a physical layer is creating a lot of flexibility to operate in all features of Ethernet. Again, this is based on 10BASE-T1L and IEEE 802.3CG, that is a standard which is using, and it supports 10 megabits per second full duplex communication over a twisted pair cable, and that cable doesn't require any certain standards or any kind of shielding, and it can be simple screw terminal also. We'll see the connector aspects of that, and it support the good part is that it supports both transfer technology, which is very famous in the industrial or a process automation side, plus it supports all industrial or Ethernet topologies also. So typical distance of APL is 1000 meters. So at a stretch, it can go up to 1000 meters. One condition when we go for an intrinsic safety, which is in the zone 0 in explosive area, it can support up to 200 meters because of the power limitation. So this is what happened when single pair Ethernet or APL is realized into the field. So you can see that there are field devices, even some of the field devices are explosion proof also. So when you're talking about the different layers or field level to the factory and control and enterprises level, field to boardroom, we are using one technology, Ethernet. In between that, APL to the standard Ethernet, we have to use some various power switches, and as well as some of the gateway aspects we need to consider that we'll go in detail in our next session. And compared to 4 to 20 milliampere HART, HART is delivering approximately 36 milliwatt in the field, but when it talks about Ethernet-APL, it can do up to 500 milliwatt power. But again, subjective to 500 milliwatt is not applicable when we talks about intrinsic safety, oil and gas. So there, definitely we need to compromise on the power that can be calculated based on the customer requirement and based on the installation. And this again ruggedized, and its assembly to the field is very easy. It doesn't require any special connector for that. And with the help of a screwdriver, we can use a normal terminal connectors also for this, and it deliver up to 10 megabits per second speed. So this is just a comparison about 4 to 20 milliampere FieldBUS and standard Ethernet with a 10x T1L. So first comparison is single pair cable. It's a 4 to 20 milliampere FieldBUS support a single pair cable, but standard Ethernet will not support single pair cable. Only Ethernet-APL will support. In terms of speed, of course, the communication like 4 to 20 milliampere FieldBUS is 1.2 to 31.25 kilobits per second in a half duplex communication mode. Of course, Ethernet support 100 megabits per second full duplex, but that is not completely compatible for industrial automation side. But with the two-wire connectivity, APL support up to 10 megabits per second full speed. And connectors wise, again, it support type A connector, but again, we can go with the standard screw terminal kind of connectivity also. Trunk length is up to 700 meter in case of FieldBUS, which is again designed for industrial automation, precisely I would say the process automation side. And 10x T1L up to 1000 meter, which is 1 kilometer, but the spur length is 200 meter. And compared to FieldBUS, it is much advanced. And screw type connector and the polarity independence and intrinsic safety operations, as well as one network topology from field device to the enterprises, all this it will support. So that's the high level comparison. With this table, you can visualize that what exactly the impact of 10x T1L is going to revolutionize into the process automation side. So let's talk about what is intrinsic safety. So I just want to give an introduction how intrinsic safety and why it is important in terms of power. So there are when it talks about explosive area or hazardous area, there are two kind of zone. One is a safe zone and another is a hazardous area. So in safe zone, what happens? There is an intrinsic safety barrier which will ensure that the field power is limited to the energy level. So the intrinsic safety is something like that. We need to minimize the energy level less than the ignition. So it should not create any ignition because of spark or a hot surface or any other flammable medium that can cause over vapor, gases or debris, dust or chemicals. So that power optimized design or critical electronics is very much important. For that, this particular communication interface also has to support on that. So generally 4 to 20 milliampere and FieldBUS has a compatibility, but it has some special kind of a design requirement. So this is one classic example how the zones are divided. So there are zone 0, which I can say inside a gas chamber, which 100% explosive elements are present. Around this area, which is very close to the zone 0, we call it as a zone 1. Again, you can see that there is another storage area, which is again zone 0, and which is close to this the station, which is a zone 1. And zone 2 is which is mostly close to this zone 1. So the chances of explosion or hazardous is more into zone 0 and zone 1. So basically, when we are designing any electronics which is for the process industry, we need to ensure that which zone it is. That's something which we need to classify it, and based on that, the complete electronics and the data transmission power has to calculate it, so that it should not create or generate any energy that will cause ignition. So this is the network sample, how exactly it is working. So you can see that these are the field devices. So there are two kind of field devices. One is in different zone it is operating. So here I can show you there is an APL field switch which is taking this increased safety Ethernet connection, and it is dividing to the field. So this is something completely intrinsic safe zone, and we are using a different color code here how it is distributed, and it is going to a power switch, because this power switch is distributing to the power to the field switches, and field switch is distributing to the power. And always, since this APL is compatible for the intrinsic safety aspects, we have to, it is easy for us to design that compared to the other protocols. So the energy limitation can be designed very well in the field device side. And when it is going to the enterprises side, of course, from this APL power switches and here onwards, we'll be converting into standard Ethernet, or we can say that the facility internet, and that will connect to different workstations, control systems, asset management, IoT monitoring. So we'll go in detail in next slide. How do we architect in a different platform? So this is a network topology which I already discussed, that it supports various topologies in the or all Ethernet network topology in terms of connectivity aspects, and plus it supports bus pur technology. This is the way generally it will work. There is a host devices, and in between that we have a junction box which will give a distribution to the field, which is called as spur. So this is the typical architecture of bus pur technologies. So this is again in terms of speed, how single pair Ethernet and a different Ethernet is compared. So Ethernet-APL, since it is a physical layer, it supports all level of protocol like Ethernet-IP, HART-IP, OPC, or Profinet. There is no change in terms of application layer protocol. But of course, it's giving with the 2-wire with the maximum length of 1000 meters, we can get up to 10 megabits per second. So compared to other Ethernet topologies, we can see the distance versus speed. So of course, in some cases, even though if you're getting a better speed, but the distance of or the cable length is very much minimized. So when we talk about the process automation, distance is very important, because you can see that we may be using a big plant automation. In that cases, some of the storage of oil or gas or any other explosive that could be away from the factory. So distributing the power and as well as the data, it's need a complex panels and a complex wiring. But with 10/T1L connectivity, we can get up to maximum 1000 meter distance and plus 10 megabits per second speed. So this is our general APL terminology. Before jumping into a detailed infrastructure and different components, I would like to explain what exactly the trunk. So when we talk about APL, from power switch to the field switch, we call it as a trunk. That something is 1000 meters. So consider this is a plant, and something is located in the field devices, which is up to 1 kilometer. We can use this APL, and we can connect to the APL switches. So this has again high power and signal strength, so it can power this field switches. There is no needed dedicated power cabling to the field. But from field to field devices, which is a 200 meter, we can route the cables, and again this can distribute the power to the field devices. So consider this is an intrinsic safety area, or this is a SADAS area. So this is a different topology. So when we talk about the star topology, there is from the field level, you can see that Ethernet increased the safety area, which highlighted in orange color, and standard APL connectivity, and this green color is indicating the facility internet. So this is a very typical architecture will work, because when you are using a 2-wire Ethernet, in between that, definitely you have to use an APL field switches, which will convert our single pair connectivity to standard facility Ethernet, so that can connect to the enterprises applications. So here you can see an auxiliary power, which is powering to the field switch, which is connected. There are 2 field switches are connected here, and that is powered by auxiliary power. And with this switches, the entire system can be powered using this 2-wire connectivity. So this is a typical star topology. which is used in the process automation side. And long field cabling, again, you can see that multiple power switches we have used here. Again, there is an auxiliary power which is connected to the APL power switches, which has a two subcomponents. One is connecting to the local connectivity, and using another gateway or a cloud or a concentrator, we can connect it with another Ethernet connectivity also for redundancy aspects. And the power is distributed to different two power switches, and again power switches is extended for multiple distance. So major power switches distributed to one power switches, and that is connected to two APL field devices, and that is extended with different APL power switches. So the field switch is nothing but normal standard Ethernet switches, but it has a special capability to power data, power over data. So it is similar like our power over Ethernet. So this is a topology which covers the complete automation pyramid. So whatever I have discussed. So here the same extension of the previous slide, there are field devices, which is again increased safety. The orange color indicates the power area, which is power sensitive area, and this is again APLs, which is extended with different field devices also, and again it is connected to the gateway. So it's covered all layers of automation, like from field devices, and there are processing elements, there are ERPs, and there are cloud aspects related things, which will cover all the data analysis, process visualization, all of the aspects. So this is the way the typical APL architecture will work, and this is applicable for any other field device also. But in this case, we are talking about the APL switch and as well as APL field switch, APL power switches. So when we talk about the prototyping and engineering, already we have discussed about the network planning, because network planning is very important here in terms of APL, how the field devices are distributed, whether it is an intrinsic safety or where exactly the power switch we are going to place it, and how many ports it is required, and how do we connect to the standard Ethernet, and what kind of gateway we are going to use it. So network planning is very important in the in this case. And typical loops, so we need to understand that how do we create various loops to connect with the different medium. So that is again part of the network planning. And all access to the instruments such as device drivers, description, and FDA packages, manuals, and certifications. So that is also very important in the engineering aspects. And instrument parameterization and configuration, which is typically when you have a device which is installed into the field, which has to be get configured. So we need to address all these aspects when you are designing anything related to APL. And instrument diagnostics during the operation. So these are something which we need to consider during our engineering aspects. So this is the APL attributes already I discussed, which is 802.3 CG is our standard, and power supply is up to 60 watt on APL trunk, and it can go up to 500 watt level, and the switch network is possible. And redundant cable and switches is optional, because like similar like in HSRP or any other redundant protocol, if you need to have an additional connectivity in case of one cable is broken and it has to communicate other cable to the field devices, like considering the SIL or any other safety integrated level, that is again optional here. And the reference cable type is IEC 61158 and type A for intrinsic safety. Cable cross section is IWG 2240. Maximum trunk length we have discussed 1000 meters, per length is 200 meters. So scalability and reliability, as I discussed, APL again operating up to a power budget of 60 watt and with a data traffic of 10 megabits per second. So APL switches we should have an APL switches which will give this kind of power distribution as well as the data connectivity to the upper level, so that it is scalable to all aspects, and it's reliable. It is again a rugged design for long distance communications. And when we talk about the scalability aspects, again APL is going to make only impact in the physical layer. So the physical layer aspects like APL switches and power switches are taken care. The rest of the upper layer, which we are talking about, the protocol aspects, which can be maintain as it is, like by maintaining the protocols like an OPC, Ethernet-IP, or a Profinet or HART-IP, we can maintain as it is. So these are some of the installation aspects. So it can go with a spring clamp type of terminal, or it's a screw type terminal where it's like one single screwdriver can use to connect it. So compared to the typical Ethernet RJ45 cable, this is much easier for us to connect it. Or it can go with M8, M12 connectors also. So this is again specified in this reference cable standard. And again, the one good advantage is that it's again providing a polarity independence. So it doesn't matter which polarity you are going to connect it. So that is also one advantage. So with all this handling and installation, Ethernet-APL is making our field level instrumentation or installation much easier compared to any other technology. Then how do we migrate to APL? So yes, that is something which since it is a new technology already, the process automation is advanced and there are many installations happening to the field. Migration to APL is one big question here. First, we need to understand the network architecture, what kind of network architecture. Based on that, we need to select the APL5, which is a physical layer chip. So probably you might be having a device which is a low footprint devices. Like most of the field devices are not working on a microprocessor. It can be working with a microcontroller also. So in that cases, we might have to select a PHY which will support SPA or an I2C, like a microcontroller level communication, which has a built-in MAC. So that is APL5 selection criteria is very much important when we're talking about the field devices. An interface with MCU and MPU, basically microprocessor and microcontroller, what kind of interfaces and how do we design that? So these are three primary elements when you're talking about the field devices. Rest all it's based on the requirement, like whether it is an intrinsic safe design is applicable or whether it is designed for hazardous operation. Yes, of course, then in that cases we need to do various power calculation, complete documentation of the intrinsic safety and the design validation, which is again time consuming task. So typically that timeline we need to consider when we are migrating to APL. Application firmware development. Of course, when we are migrating to Ethernet-APL, all of a sudden we are getting the all Ethernet support, like transport layer security for security or secure socket layer, and as well as trusted platform modules. So as I discussed in my beginning, so when we talk about automation pyramid, earlier stage what happened, we are using some of the analog or HART related protocols, which is to the field. So it's already created some kind of a water layer, so that itself is ensuring a security. But when you are enabling field devices connecting to Ethernet or direct access to the internet, security is one crucial point here. So in that case, various security aspects are to consider when you are developing the firmware. Then of course the testing aspects, so it has to go with the various type testing in the sense of course one is intrinsic safety aspect is one type testing, or anything on European conformity C or any special certification required for safety integrated level for functional safety. That testing has to take care. Then we need to plan the production. So it's a very high level migration path to APL. This is a typical process which we captured based on different customer requirement analysis. So what Utthunga is offering on APL aspects, one is migration from FieldBUS to APL. Any legacy devices which has to migrate from any of the field devices to APL, which I explained in the previous slide. That's something which we can offer. And complete device engineering with APL. It's kind of a new product development. Some of the customer really wants to design a product which is compatible for APL. Definitely we can look into all other aspects like intrinsic safety aspects and various power calculation. We can do the complete end-to-end device engineering with APL. Intrinsic safe design, so that is an exclusive offering, like already the prototype is done, but it has to consider various intrinsic safety aspects for hazardous operation. Yes, that is also one offering from our side, since we are very known to various industrial protocol side, and we have our own stack and as well as support, and closely working with the FieldComm Group kind of an association, we can be your partner for various protocol development. And last and final, for IoT network architecture, by looking into all this slide, you know that how important it is for the network architecture, because we need to deal with the different layers of automation pyramid. So network architecture is very much important here. Then how we can associate, we can work with you as a turnkey project, kind of an offshore development center, or it's kind of resource augmentation, or it could be an outcome model. So with this, I am concluding this webinar. I'm open for questions.
Well, first of all, thank you so much, Jegajith, for giving us such an informative presentation. I'm sure Ethernet-APL will open many doors, and for that matter, will kind of give added capability to the communication architecture. As you were presenting, there were people who were also having some questions, which I will share with you, and I would be happy if you can answer them. In fact, most of these questions, other than a couple of them, I believe you have already covered in your presentation. Nonetheless, let me go through it. So let me follow or give the privilege to the person who made the question first. So FIFO, first in, first out. So let me read out the question. This comes from Mr. Hanuman Kadam, who writes, please explain Ethernet-APL architecture in relation with Open Automation Protocol.
This is, I think you're talking about the OPAF, right? See, Ethernet-APL is not going to make any significant impact for any kind of an open automation protocol or anything, because this is only a physical layer changes. So it supports, from my presentation itself, it's clear, it supports all any application layer standards. So only thing is that when we go for any other protocol, we need to ensure that how this physical layer is going to impact the field.
Yeah, very correct. Very correct. Would you be kind to clarify a couple of these points? These have come from Ms. Pushpa Chaudhary, who writes, does it mean the speeds of Ethernet, that is, or 10 megabits per second is the maximum? I think this also you had covered in one of your slides, that
yes,
at present 10 megabits per second is the maximum. Anyway, please go ahead.
Yes, 10 megabits per second is the maximum. I think she is asking whether it is a 200 meter, unlike a trunk, apart from a traditional foundation FIELDBUS backward compatibility. I don't understand this question specifically, but at least the 10 megabits per second we can maintain it, whether it is irrespective of trunk or spur. It's across from Ethernet-APL, where the physical layer start and end, we can maintain that speed.
Something that we also have to know is, the reference of the speeds with the change in process parameters. The process variables are by and large analog or Boolean, but they do not change also with the very high speed. So by and large in process automation, I would say 10 megabits per second suffices the need for communication speed. So I think we also need to kind of look at it with the angle of the process variable. I mean, how quickly the process variable changes in any plant. Anyway, next question, understanding the Ethernet-APL, both trunk and spur is based on the same technology, but why spur length is limited to 200 meters, unlike the trunk? I think this was also shown in one of your slides because of the power and power requirements of the hazardous areas.
Yes. Because what happened, any 46 microjoule, that is the energy limitation in any of the hazardous area. Like if you consider a small control station in any of the place, which will create some kind of a fume. So if any of the electrical device is creating a more than 45 microjoule, definitely it's a very dangerous situation or a very catastrophic situations. So to limit the 45 microjoule power, definitely we need to reduce the power also. So when we talk about a long distance communications, of course we need to reduce the distance, because the moment when you reduce the distance, the power transmission over the cable is also limited. That's the reason, as per the standard, that is limited up to 200 meters.
Yes, we have to ensure that the network is deterministic, and for that matter, the signal and the process variable or the data which is coming in is also very legible and authentic. One more point, or rather it's a comment which has come from Jonas Burge. Welcome, Jonas, who writes that the FieldBUS Foundation can now be, with 1900 meters. Please see the latest table, which or the final, paper which has been launched in June 2021. This is absolutely correct. I think it's only an addition to what has been done before. So that certainly is a good step. Your point is very well taken, Jonas, and thank you so much for your input. The next one again comes from Ms. Pushpa Chaudhary, who writes, is related to the APL power switch. We say that auxiliary power is needed for APL power switch. Is it optional? Obviously, I mean, it can be powered from the higher layer. Jegajith, there was one slide where you showed an auxiliary power which was powering the APL switches. I think she is referring to that particular slide.
Yeah, so if you see the standard switch, what happened, say example, my power demand to the field is more. In that case, my switch don't have a capability to power that much. So it's like an additional power supply, but definitely power over data. Like we don't have any other source to give, because definitely the power should have a source, right? So my field, say example, I need 20 watts, 2 systems. So total, I need a 40 watts power. So power has to give somewhere else. So I cannot take it from the field switch. So it is a representation that the auxiliary power will give an additional power, which based on the field demand. So yes, it is not mandatory that you need to have an extra power supply. Say example, in future, people are still working on the power switches. So I don't have any authentic information till today. But if tomorrow somebody is building a power switch, definitely they will mention the maximum power that we can derive from one port. So based on that, we can plan.
Yes, I mean, they would try to derive as much power as possible depending on the network requirement. Not a problem, absolutely, and that's well taken. One more question is about, can you give one example of FF to Ethernet-APL? Well, these are two different physical layers, but okay. Can you take this question?
Yes.
Jegajith?
Yes. So foundation FieldBUS, we can conversion. We need to have a special microcontroller or anything converter device. We need to design it. So it's like if you make a small block, then of course we should have a foundation FieldBUS in other side, and we should have a microcontroller sitting on other side to decode this foundation FieldBUS data. Then plus we need to have a physical layer which is compatible with the APL. Then of course this microcontroller will decode this data, and that can put into the APL side. Of course, when it is talking about the APL, we should again maintain some Ethernet protocol. So foundation FieldBUS to HART IP or anything compatible based on the requirement, you can plan it. But it's need a processing component, kind of a microprocessor or a microcontroller.
Yeah, those interfaces will be there, no doubt about it. The next question is also, I would say, a corollary of the same thing, whether Modbus TCP IP is supported.
Of course, anything on application layer, there is no change.
If you don't mind, can I share one slide, Jegajith, with all of you? It shows a bigger picture of how the legacy devices of Foundation FieldBUS, of wireless HART or HART IP, everything will be integrated into one big model. So give me just a second. I find this slide very interesting. Just give me a second that I can present it to you.
I think, Harish, we have one more question, like how 60 watt power.
No, I'll simply come back to you for that as well. I was just trying to show just one. Okay, I hope this is visible to you. Maybe I can just make it a little bigger. This is not to answer any question, but just to show you a bigger picture. Just give me a second. Yeah. As you can see here, I mean, whether these are legacy devices or whether it is Foundation FieldBUS devices, through a gateway, of course, I mean, it can always come to Ethernet, APL. And even the wireless HART or HART IP devices or devices maybe tomorrow on UPC, OPC UA, all of them can be hooked onto the same bus. So for that matter, this is much more, I would say, open to accepting any protocols. So whether it is Modbus or whether it is standard HART devices or HART IP or OPC UA devices, they all would be able to come on the Ethernet platform. Okay, coming back to the presentation again. And the last question here, because we're running out of time again, it's about, it's coming from Mr. Krishna Manjri, who asks how 60-watt powered infusion can form an IS design, an intrinsically safe design.
I think it's not possible. 60 watt is possible actually when you give an explosive enclosure, that is possible to make sure that there is no spark or something is creating or outside the world, or it is not interacting with the any of the debris or the fumes. So in that case, 60 watt is possible. Generally, for any other intrinsic safety, 60 watt is really tricky thing. It's an explosion-proof design, I can say, not intrinsic safe design.
Very fair. I must say there are also compliments coming into you from Mr. Suresh and some others, about your presentation and the content. So I would say very happy that Jegajith, you could spare time and share your points of view and also share technology insights of Ethernet-APL with our audience. Please remember us. We would be very happy to support you. We can also send you more information on Ethernet-APL. We have the white paper ready, which is also there on the website, a newly launched website of the FieldComm Group. You can access a lot of information there. And of course, we'll be also very happy to send you the information, whatever you desire. We as a company, that is FieldComm Group India Society, we are more engaged in disseminating information. We are vendor neutral, and we are here more to disseminate information to you people, and also to kind of share with you the advantages of the technology that is being worked upon and which will become a standard in the near days to come. So thank you one and all for making this nice webinar. Thank you, Jegajith, for making the presentation. Thank you all the people who spared their time during the afternoon today to listen to us. And I'm sure you all have some good takeaways from this presentation. Should you need some more information, we would be very happy to support you. So